Okay guys, we are doing day 7 today, so I have the notes page up from the booklet for you guys. This is very similar to what you did on day 6. Today we're just going through some word problems. So you have the notes here, so it's just reminding you to draw a diagram, and then you're going to write a trig equation, to find the solutions here. So we're going to go through example problems like A and B, so feel free to look over those for additional help as well. Otherwise, we're going to dive right in, and hopefully today will be a short day of notes. All right, so the directions say draw and label a diagram to represent the information, and then write a trigonometric equation, and finally solve the problem by using the inverse trig operations. So let's get started with number 1. Number 1 says a 50-foot building casts a 37-foot shadow. What is the angle of elevation to the sun with respect to the ground? So we'll start out with our diagram here. So we're going to just do a right triangle for our diagram here. And it says our building is 50 feet. So we're going to label this side over here as 50 because that's going to represent the height of our building. And a shadow is 37 feet. So guys, remember a shadow is going to be on the ground here. So we're going to label our second side 37. So it says the 50-foot building casts a 37-foot shadow. What's the angle of elevation? So remember, the angle of elevation is when we start from the ground. So it's going to be our little theta there. So if this is our theta, we need to label our other two sides to determine what trig ratio we're going to use to solve this. So over here we have our opposite, and 37 is our adjacent. So opposite and adjacent is going to be tangent. So we are going to write the tangent of theta, because that's our angle. So the tangent of theta equals opposite, which is 50, over adjacent, which is 37. So just like you guys did yesterday, you're going to get your calculators out, and you're going to take the second and then hit the tangent button. So you have the inverse or the arc tangent, and then you're just going to plug in 50 divided by 37. And you're going to get 53, let's round to 1 decimal place, so 53.5 degrees. So remember, you need to complete a sentence for your final answer. So the angle of elevation is 53.5 degrees. And that's number 1. Number 2 says a 40-foot ladder is placed 15 feet away from the base of a house. Find the angle of elevation the ladder makes with the ground. So again, draw in your diagram. We're going to start with our triangle. And it says a 40-foot ladder. So think about what a ladder looks like when you're using it. You do not line it up directly next to the building. It can't be laying flat on the ground. It's going to be what makes this angle in the triangle right here. So we'll label that side 40. So our ladder is 40 feet, and it's placed 15 feet away from the base of the house. So here, over here, if that's helpful for you, you're going to draw the house in. So it's 15 feet from the base of the house. So that's going to be our side right here that we're going to label. So it says find the angle of elevation the ladder makes with the ground. So again, down here, that's going to be the angle that we're solving for. So now we're going to label our sides of our triangle, and from there figure out what trig ratio we're using. So we have opposite, so 15 becomes our adjacent, 40 becomes our hypotenuse. So adjacent and hypotenuse is cosine. So we're going to take the cosine of theta equals, and remember we just said it's adjacent over hypotenuse, so 15 over 40. Same thing again, go ahead and plug that into your calculator. So I'm going to do the second button and then my cosine, and then I'm going to do 15 divided by 40. That's going to give me 67.97, so let's round that up to 68.0. So the angle of elevation is 68 degrees. All right, 2 more to go. 3, a rectangle is 48 inches long and 25 inches wide. Find the measure of the angle formed by the diagonal in the shorter side of the triangle. So again, remember, our diagram for this is a rectangle. So for this, we're going to draw a diagonal right through our rectangle, and that's going to give us our 90-degree angles there. So it says a rectangle is 48 inches long and 25 inches wide. It says find the measure of the angle formed by the diagonal on the shorter side of the rectangle. So that's going to be our angle right here. 25 is our shorter side, so we're just looking at this top triangle here. So now we need to figure out what sides we're going to label. So we have adjacent right here for our 25 and opposite for our 48. So opposite and adjacent are going to be tangent. So we don't know our angle. So tangent of theta is opposite over adjacent. Plug that into your calculator. You're going to hit the second button to get the inverse of tangent. And then you'll do 48 divided by 25. So we get 62.5. Go ahead and make sure you write out a complete sentence. The measure of the angle between shorter side, diagonal, and short side is 62.5 degrees. And the last one, number 4, says a jet reaches its final cruising altitude of 15,000 feet, approximately 13 miles from the airport. What was the angle of elevation during the plane's ascent? So again, we'll do our drawing, our diagram here is going to be a triangle. We'll do a 90-degree angle. And the information given to us, it says a jet reaches its final cruising altitude of approximately 15,000 feet. So we're going to label our side over here because that's the height of our jet. It's the highest point that we reached was 15,000 feet. Now here, this is labeled in feet. It says it's 13 miles from the airport. So as our plane is flying, we know that this is going to be on this kind of uphill angle, this side over here, the hypotenuse of the triangle. However, it's 13 miles, and we need them to have the same label. So we're going to convert that little hint that's given to us. So we are going to do 13 times 5,280, because we know that's how many feet are in a mile. So we have 68,640. So we have our two sides labeled, and it says, what was the angle of elevation during the plane's ascent? So we're going to solve for this angle. So we have our opposite, and we have the hypotenuse. So for opposite and hypotenuse, we have the sine of theta equals 15,000 over 68,640. So we're going to plug that into our calculator. Second, sine 15,000 divided by 68,640. And our answer comes out to 12.6 degrees. So our final sentence would read, the angle of elevation was 12.6 degrees. And that's all for day 7.